Alright, we backed that one off with a wrench to where we can start screwing it by hand. And we're about 1,475. And pretty close to the same thing here. Alright, we're going to take a little bit on each one. There's about a half a turn there, and a half a turn there. Getting closer. Pretty close. Alright, if you think it's close enough, then we'll go ahead and we can check it with our .1505. .1498. So we're within 7 thousandths of in the end right now, and we just need to come up 50 thousandths. And these are 3/4 10, so a half a turn would be 50 thousandths, right? I think that was about a half a turn. This one here. I think that's pretty close to a half a turn. .1530, 1,520, 1,555. $1,550. Alright, now we're going to go ahead and we're just going to crank in both sides here until we get it split the difference, and we're going to do the same thing, and we'll 4-point this, and we'll bring you back to where I have it all scaled in, and then we can go ahead and put an indicator on here, just kind of sweep it, and we can fine torque it from there. Okay, I'm within a couple thousandths, both ends of this tube, and this is 100 thousandths oversized. We're going to bore through and create a finish ID, and then we're going to be cutting off the flanges in the plasma cam. Come back and we're going to put them in the four-jaw and bore them so they'll slip over the outside, and we'll have a weld prep put on these, and the 2 flat flanges that go on here, and we'll get those welded up. But right now I've got this set up, and we're going to go ahead and finish locking down our jam nuts. We already locked the ones down underneath. So the tube is mounted solid to the carriage now. Now we're going to go ahead and we're going to look in our tool bits, and we're going to find out what we got that will fit our holder right here. Alright, this is a VR/W. I'm not sure the actual brand name. AL8. This is a 1/2 inch. It was 8/8 is a 1/2 inch, and it's been ground back at an angle. I had a relief. I kind of dressed that, and then I ground a top side breaker in there, and we're going to see if we can go ahead and get the chips to break instead of curling up in here. And right now I'm just kind of jacking in till I can visually see about 50 thousandths on the side here. That looks like it's going to touch there. Alright, we're going to lock down our 2 set screws here. There we go. Alright, we're going to clear the deck here, and let's see, we're going to be turning forward, and we're going to be feeding forward. It's going to be kind of simple. I think that this is the speed we were turning the OD of this. I think I'm gonna start there anyway. All right. All right. Here we go. Let's give it a shot. We're gonna feed it, touch it by hand first. Touching. I'm not sure on the feed yet. We're going to try, this is our coarse feed. I just want to make sure we're not taking too much. Looks like a pretty good bite there. We're turning out almost 100 on this side here. And we'll check the wall thickness as well here. We know it's going to be finishing up about 5, and right now that would be close to 550 because we have 6/100 there, and right now we're real close to being 600, 610 all the way around. Alright, I gotta grab a pair of spring inside spring calipers. Alright, we took our calipers and what are you doing, Shanann? Meow. Meow. You talking? Alright, basically 895. So we're at 4900, and we got 6/100 here. And we took these spring calipers, and our thickness feels pretty close to the same all the way around. I am very tempted, and I think I'm going to go ahead and let this cut run through. The cut looks good. I was doing a good chip here. I'm actually hollowing out 100,000ths out of the side here. On this side here, and this side over here looks like about 20, but we know that it's not 100% perfectly round on the inside. We've seen that on our setup with our bell centers. So I think I'm going to give it a shot at letting it run through. Alright, let's clear off our stuff here and pick up our light. Hang on, I'll let you out. Alright, I'm going to ease back into it here. Alright, and engage our feet. And here we go. Alright, we just came through. We just pulled out all of our chips in here. And we're taking our spring calipers here. and we're kind of just checking the feel, 4-pointing, checking the feel. We're real happy. Now, I think this is what we got on the other side there, and we want to see what we got as far as the diameter in here. Four inches 896. We're about 4 inches under 900, so we have basically a roughly 100, 110, 105 to 110 would probably be ideal for finish. So half of that is 50, 52, 55, somewhere right around in there. Let's come in, I'm going to come in with 25. See if I can do it in 2 cuts, because I just want to make sure that our bit's going to last all the way through. And I want to see what it's doing on a little bit lesser amount on the cut. And I was real happy with the way this broke those chips. And the average chip in here, is probably, I don't know, 60 thousandths or so. Some of the bigger ones are every bit of 100. $75 and 100. Here's another one. 85. So that really was a real good cut. Alright, so let's go over here and I'm going to show you how I'm going to set up and adjust my depth of cut. Alrighty, I'm getting ready to adjust this, and all I've got to do is undo my set screws here and then crank in the little screw on the back side. And if I roll this over, you can see that it has adjustment. Now this is a sleeve that you can buy readily made, except for the set screw holes. That was my own gig. You put it in there, you align it, and then you do your machine work. You got to bore and ream out a hole for it, and you put in your set screw holes, and then the thing slips in there, and then when you put in your inserts, it keeps it in position. And your adjustment is semi-tension, and it takes just another Allen wrench there, and it gives you that fine-tuning adjustment. I'm going to show you how I'm going to go and set this for my next cut. But before we do that, I always get asked what that is. So I even have a page in here marked now. Find the right mark. Every page is marked in the book. It seems like it sometimes. All right. Low carbon steel square hole tool bit sleeves is what they're called. And I'll take a picture of this right here. And the one I'm running in here now is the 1/2 inch. All right. And as far as the cost on it, the one I have in here is $21.27 plus your shipping and handling, and they're going to charge you tax on top of that. And you know, that's so really, if you're going to have gonna need them, you order a couple of them. You know, it's kind of nice. I have 3/8 and 3/8 and 1/2 inch are probably my most common that I use, but they have them all the way from 3/16 up to 1 inch. All right, so what we're gonna do is I've taken and setting up, this is plungers kind of like straight down, and I set it up so that you can slide it. This is another purpose. This flat is really chip clearance, but it is real nice to go ahead and run your mag base right on there, and then you can get that plunger going straight in. Alright, now what I do is I set this for 0 right here. And then I can go ahead and loosen my hold on the tool bit. Then I go ahead and come in the back here and jack in what I want. We had 105, 110, something like that to go, and I said I was going to take like half of it, and I put in 25 thousandths. We're going to take 25 thousandths. I always kind of double check it. It's actually 25 and a half now that I've tightened this up. So you just want to be cautious of when you get down to the nitty gritty, watching that needle, so that when you tension it up, you might have to back down and then retension it. But check out your dial. Just don't take it, look at it, tighten it up, and then think you got there, because it may actually suck in a little bit more than you had, only because of the position as you're pushing this tool bit out and the way you tighten this. And always set it at 0 before you loosen it. This is 25 thousandths per side, and we're cutting about 265 on the RPMs, and we're feeding it about 13 thousandths on the feed per revolution. Well, that's a nice cut. Now I have had to stop it a couple times through the pass here, and I just stop the feed, and then I stop the spindle, and I pull everything out, and I start it, and I start the feed, and you know, I've got a nice finish in there right now. And you can see why I'm stopping it, because it builds up and starts twisting around. This material, after it's cut, is super hard. You don't want to get caught by them chips there, that's for sure. They are hard to pull off, they're hard to break. Okay, right here I'm just going to go ahead and stop it now, because when it starts getting a little chewy like that, I know it's got a pretty big ball here that's interfering with the cut. Okay, and then grab with my pliers very carefully. It's like wire. Spring wire, really. Kind of glad when you can get them to break. And actually the first pass there was really nice with them breaking. That was about 50 thousandths. This is 25 per side. They don't tend to break. And of course I haven't played with my feet or anything. I could probably do that. I'm going to have one more pass in here or so. We're going to see what it looks like. Alright, we got the big wad out of there, so now we can start it up again. And it continues off again. And you know, it's still cutting fine. It doesn't even leave a line in there where I actually stop it and start it. take a look at our bit here. Just want to see the edge on it. It's actually holding up really nice. Alright, we got to take some measurements on our bore. $9.45. See what we got on this side here. Feels the same. I didn't even change it. $9.46, something like that. My second to last cut, I was right at matching numbers with my part, and I fed in 2.5 thousandths on the tool bit to lightly take a skim cut, and I'm equal side to side. And I'm going to check this with inside micrometers when I get all done pulling it out of here. But I'm measuring right here 5 inches 6 thousandths. So we'll see what it is when I get it slid out of here, and we're going to get the other one and start cutting it. All right, now I mic'd both of the outsides of these, and we're right within 1,000 or so. So I'm going to go ahead and I'm going to see if I can't, how close this is by just loosening these two on this side here, sliding out the ring. And sliding in a new one. We'll still have to adjust it because I'm sure there's a little bit of this pressure and everything else that's on here. And does look pretty nice. I have to wipe out some of that oil there and get a look at it. Okay, here goes in the next one. And we just kind of split the difference in there. We go this way and make sure that we have plenty of exit room. And we do. Okay, we'll bring in our tailstock and we're going to set up our indicator and sweep it, and we'll get this one set in just like the other one. And then we're going to set the other one up and we're going to find out the wall thickness and the diameter that I ended up with. Okay, I didn't break that edge. I'll break those later. And what I'm going to do is just going to put my calipers down all the way so that everything is exactly the same. All right, we're reading 550, 548, 551, 547. All right, so we're really close right there. And we have 100 thousandths more to take off on the outside yet. Now, I've taken my inside micrometers here. And of course they read 5 inches 6 thousandths there. And we'll see if they match up with the mic. And they do. Alright, so my reading with my spring calipers inside there was exactly right. And I was shooting for 5 thousandths over the pin size. And I'm probably 4 or 5 thousandths over the pin size. And we'll keep an eye on this diameter here when we get ready to weld on that in plate there. Alright, we're happy with our progress on the sleeve. Nice finish in here. We'll probably run the BB hone or something in there just to go ahead and finish it off. And I did have just a little tiny bit of vibration here, but not bad at all. The second to last cut was better than the last cut. And it was just on that one end, and I think it was just the tool bit was getting dull. I ran the tool bit from roughing to the finish. Normally somewhere in between I kind of get a halfway there. It's very nice. I'm happy with it. Okay, I'm holding this as still as I can, and I'm kind of coming in and see if I can keep it in focus here. Okay, this is looking at our bit before we go resharpen it. The bit really doesn't appear to be extremely worn, chipped, or broken. Okay, that's kind of looking at the nose of it, about the best picture we can get there. Alright, I'm going to go throw an edge on it before we put it in for this next part. I was within 10 thousandths on this side here for the first adjustment. I had to lower it down a little bit. I haven't had to break this side up here, but I've tensioned this, lowered the bottom down, and I didn't check this side before I made any movement. I should have, but I didn't. I was just in a hurry of getting it done, that's all. Like -5 down there. It's like +5. -10 over there. Minus 5, minus 5, minus 5, minus 3, 2, that's almost minus 5 all the way around. So it's maybe minus 4 in one spot. Alright, let's see what we got over here. Pretty close to 0. Minus 5. Minus 5. And we got 0. Minus 2. Minus 0. Minus 3. Minus 5. Okay, we're gonna crank this one down just a little bit. About minus 1. Minus 1. Minus 1.5. And we're about minus 5. Minus 3, minus 3, minus 3, minus 2. Okay, we're good. One check on the other side here, and I think we're going to be ready to let it fly. Zero, 0, 0. And check and make sure that that's so close. Alright, we're going to call that 0. We're ready for a cut.